right. This one is really beautiful. We've got a right triangle, A, B, C. The right angle is at B. Angle C is 36 degrees, and the hypotenuse, AC, has length 2. We need to find the base, BC, which is x. And here's the catch. No trigonometry. No sine, no cosine. Just pure geometry. So we need a different idea. Here's the trick. Extend the bottom side to the left, past point B, to a new point P. Now connect A to P. And choose P carefully so that angle APC is also 36 degrees. Now look at the big triangle we just created. Triangle APC. Angle at P is 36 degrees. Angle at C is also 36 degrees. So the triangle is isosceles, which means the opposite sides are equal. Since AC is 2, AP is also 2. Now, look at the two right triangles sitting side by side. Triangle ABC and triangle ABP. Both have a right angle, both share the same height, and both have hypotenuse 2, so they're congruent. That means the left base, PB, is equal to the right base, BC. And since BC is x, PB is also x. So the full bottom length, PC, is 2x. Keep that in mind.
Now comes the next construction. Extend the line PA upward to a new point Q. Then connect C to Q. Choose point Q carefully so that angle ACQ is 36 degrees. Now let's examine the giant triangle, PCQ. Angle at P is 36 degrees. Angle at C is 36 plus 36, which is 72 degrees. Because all angles in a triangle must add up to 180, that top angle at Q has to be 72 degrees as well. That means triangle PCQ is isosceles too. Now look at the smaller triangle on the right, ACQ. Its top angle is 72. Its bottom angle is 36. So its third angle, right near the middle, must also be 72. So that triangle is also isosceles. Since AC is 2, CQ is also 2. Let's call the small top segment, AQ, equal to A. So the full left side, PQ, becomes 2 plus A. And because triangle PCQ is isosceles, its bottom side, PC, is also 2 plus A. Now we use one final idea: similar triangles. The large triangle, PCQ, and the small triangle, ACQ, have the exact same angles. So their side ratios match. Set up the proportion. 2 plus A over 2 equals 2 over A. Cross multiply. A times 2 plus A equals 4. Expand it. A squared plus 2A equals 4. Move everything to one side. A squared plus 2A minus 4 equals 0. Now solve the quadratic. Using the quadratic formula, we get A equals -1 plus or minus √5. Since A is a length, we ignore the negative solution. So A equals √5 minus 1. Now, go back to PC. PC equals 2 plus A. So that becomes 2 plus √5 minus 1, which simplifies to √5 plus 1. But PC also equals 2x. So 2x equals √5 plus 1. Divide by 2. And finally, x equals √5 plus 1 over 2. And yes, that is exactly the golden ratio. Pretty amazing, honestly. A simple 36-degree triangle quietly hiding one of the most famous numbers in mathematics. All right, see you in the next one.